Welcome to this explainer. If you spend any time staring at the CPT codebook, you already know the integumentary system can feel like a massive, complicated maze. It's enough to test anyone's sanity, right? But what if we could take those dense, giant paragraphs and flip them into a highly visual, super easy to remember decision tree? Well, that's exactly what we're going to do today. We're stripping away all that confusion and mapping out the CPT guidelines for skin procedures. Let's just dive right in.
To help you really master this, we're going to follow the natural progression of an actual surgery. We'll hit the integumentary foundation, diagnostic procedures and biopsies, excisions and their margins, the 3 tiers of wound repair, and finally, advanced closures and grafts. Basically, we're starting right at the skin surface and digging all the way down into complex reconstruction. All right, part 1, the integumentary foundation, or as I like to call it, understanding your canvas. Because before we can even think about coding a procedure accurately, we really need to know what we're working with. This cross-section brilliantly shows us the 3 main layers of the skin. Up top, you've got the epidermis. Right below that is the thicker dermis. That's where your hair roots and glands hang out. And down at the very bottom, that's the fatty subcutaneous tissue. These 3 layers are your absolute foundation for coding. Seriously, your whole coding process hinges on one simple question. Exactly how deep did the surgeon go?
The entire integumentary section relies on figuring out which of these specific structures was altered, removed, or patched up. Think about it. If a surgeon just shaves the epidermis, you're looking at one code. But if they cut way down into that subcutaneous tissue, that is an entirely different ballgame with totally different rules. Being able to visualize this anatomy in your head is your absolute best tool.
Moving on to part 2. Diagnostic procedures and biopsies, basically taking soil samples. If surgery is a major construction project, a biopsy is just checking the dirt before bringing in the heavy machinery. Now, CPT guidelines are super strict here. You have to categorize biopsies into one of 3 distinct techniques. First, there's the tangential biopsy. Think scraping, shaving, or scooping. Then you have the punch biopsy, which, no surprise, requires a literal punch tool. And finally, the incisional biopsy, where they use a sharp blade to take a full-thickness slice right down to the subcutaneous space. The tool used and the depth reached, those completely dictate your code. You can literally see the difference right here. On top, that tangential biopsy is just using a flexible blade to shave off a partial thickness sample, nice and shallow. But check out the one below it. A punch tool is used to core out this perfect, uniform little cylinder of skin that goes much deeper. That clear visual distinction is exactly what drives your coding choice.
All right, part 3. Excisions, measuring, and margins. This is where we start digging the foundation. Let's say that biopsy comes back and the provider needs to completely remove a lesion. That's an excision. Here is the absolute most crucial point. A true excision has to be full thickness. It must go completely through the dermis. If it doesn't break through that middle layer we talked about earlier, it's not an excision, it's just a shave removal. And here's the fun part. To code an excision correctly, you can't just guess the size. You actually have to use a very specific mathematical formula. Yep, as coders, we have to play part-time geometrician. To find the quote-unquote excised diameter for your code, you follow these exact steps. Step 1, measure the widest part of the lesion itself. Step 2, find the narrowest surrounding margin the doctor removed. Step 3, multiply that narrowest margin by 2, because, there are 2 sides to the lesion. And step 4, add that margin total to your original lesion diameter.
Let's look at how this math plays out in real life. In this example, the patient has a 1.0 centimeter melanoma. The surgeon takes a 2.0 centimeter margin around it. So following our formula, we take that 2.0 centimeter margin, multiply it by 2, and we get 4.0 centimeters. Add that to our 1.0 centimeter melanoma, and boom, our total excise diameter is 5.0 centimeters. You'll base your code on that final number no matter how they end up closing the wound. Which brings us nicely to part 4, the 3 tiers of wound repair, the masonry work. The foundation is dug, the lesion is out, and now the surgeon has to close the hole. CPT guidelines group these closures into a really strict rule of 3. At the basic level, we have simple repair. This is for your superficial, one-layer fixes, just the epidermis or dermis. Stepping it up, we have intermediate repair, which requires a layered closure of the deeper tissues. And then at the very top tier is complex repair. This is for intensive reconstructive work, like when bone or cartilage is exposed, or when the surgeon has to do something called extensive undermining. Now, I know a major pain point for practically everyone is telling the difference between intermediate and complex repairs. I mean, they both require layered closures, right? So what actually tips the scale?
Well, the deciding factor is very often the presence of that extensive undermining we just mentioned.
But what does extensive actually mean? Thankfully, the CPT manual doesn't just leave it up to our feelings, it defines it with math. Extensive undermining means the surgeon had to free up the surrounding skin over a distance that is at least as wide as the maximum width of the wound itself, measured perpendicular to the closure line. Let's lock this concept in. If you follow the line of closure down the middle of this defect, the maximum width is 2 centimeters. Now, notice those arrows pointing outward under the skin? The surgeon has undermined or freed up the tissue for a distance of 2 centimeters. Because that 2 centimeter undermining distance perfectly matches the 2 centimeter maximum width of the defect, it officially qualifies as extensive undermining. And just like that, this procedure gets bumped up into a complex repair code.
Finally, part 5, advanced closures and grafts, rebuilding the wall. Sometimes a standard linear repair just isn't going to stretch enough to cover the hole. That's when surgeons have to essentially rebuild a missing wall using materials from somewhere else.
When a surgeon performs an adjacent tissue transfer, we're talking procedures like Z-plasties, W-plasties, or rotation flops, a very special rule kicks in. The guidelines explicitly state that you do not code the initial lesion excision separately. It's totally bundled. The whole shebang is rolled right into the tissue transfer code. And the geometry of a flap reveals something really interesting. When you move healthy tissue to cover the initial hole, which is your primary defect, you inevitably create a brand new hole where that healthy tissue used to be. That's your secondary defect. Look at Area 1 and Area 2 on this advancement flap. To pick your final correct code, you actually have to calculate the square area of the primary defect, calculate the secondary defect, and add them together. You are literally coding for the total square footage of the reconstruction. So, what does this all mean for us? Why go to all the trouble of visualizing anatomy and memorizing geometry formulas? Well, because by seeing those distinct skin layers, doing the exact math for excisions, and mastering those repair tiers, you completely eliminate the guesswork. When your coding is just as precise as the surgery itself, you prevent claim denials, and you directly protect the financial health of the practice. The roadmap is right there in the manual. It's just up to you to follow the math. Thank you so much for joining me on this explainer, and I hope this helps you see your codebook in a whole new, highly visual way.